So occasionally you will get a function that you need to take the derivative of that's pretty complicated, such as f of x equals 3x minus 8 to the 12th power. This is an example of a complicated function. Now, based on everything that you know right now, you probably would be multiplying this binomial 3x minus 8 out 12 times. You'd get something really, really long. You'd get a polynomial with, I think, 24 terms. Not very pleasant. So we actually have a way around that. We have something that's called the chain rule that will make this problem a lot easier. So the chain rule says that if you have what we call a composition of functions, meaning you have a function on the inside and a function on the outside, then the derivative of that composition is going to be the derivative of the outside function, where the inside stays the same, times the derivative of the inside function. I'm going to actually write that with outside and inside. So right now you might be looking at this and it might look really, really confusing. So let's just do an example. I actually would like to just do the example of the one that we had up there. So we have f of x equals 3x minus 8 all to the 12th power. We are going to find the derivative of that. So when I said outside and inside, the outside function is that I am doing something to the 12th power. The inside is that 3x minus 8. So first thing I'm going to do is remember how to take the derivative of something with the 12th power. I am going to move the exponent out front, and I'm going to subtract 1 from the outside exponent. So I get a 12 out front, and my new exponent is 11. The next thing I do is keep everything that's in the parentheses the same. So the 3x minus 8 stays the same. However, we do still need to take the derivative of 3x minus 8. That's what this whole thing is going to be multiplied. So I get a 3. So my final answer for this is 36 times 3x minus 8 to the 11th power. So we have two examples that we're going to do. You're welcome to try these on your own, or you can just watch me do these. So for number 2, we are going to find the derivative. Before I do anything else, I am going to rewrite this function so that I don't have a radical in there. I'm going to change that cube root to the 1/3 power. Now this type of thing is really, really, really hard to simplify in any other way. It's not like when you have a squared, you could use the FOIL method. This one we actually do need to use the chain rule. So I am going to start by moving my 1/3 out front, and then I subtract 1 from the 1/3 power. That gives me negative 2/3. I keep everything that's inside my parentheses the same. However, on the next step, I need to multiply by the derivative of 4 minus x to the 5th, which gives me negative 5x to the 4th. If you're on the AP exam, actually you can leave it there, but I think it's probably a good idea just to go all the way to the end. So my negative 5x to the 4th is going to stay in my denominator. 3 will stay in my numerator. I end up getting 4 minus x to the 5th to the 2/3 power. And if you want to simplify that even more, we are going to change that to the cube root of 4 minus x to the 5th squared. So for number 3, this one, I think once you write it out in a different way, it gets a lot easier. So this is cosine squared x. We can rewrite that as cosine of x squared. Keep in mind that this is the same thing. The entire function is squared. The cosine squared x is just a notation for writing it. So when we take the derivative of that, we start by taking the derivative of the outer function, the squared. So we bring the 2 out front, keep the inside the same. Our new exponent is just 1. Now we take the derivative of the cosine x, which gives us negative sine x. If you simplify that out, you just end up getting negative 2 cosine x times sine x. We're going to do one more example. This one actually is a little bit more challenging than the other ones, and not just because we have both an e and a trig function. One of the reasons it's more challenging is because we actually have to use the chain rule twice. So we have that 2x inside the sine, but we also have the sine of 2x inside the e. When you get something like this, you are going to want to start from the outside and work your way in. So let's go ahead and find the derivative. So our first outside thing is that e. So we're going to do the derivative of the outside times the derivative of the inside. So the derivative of the outside, the e, just ends up being e again. We keep the sine of 2x the way it is. Now we multiply by the derivative of the inside. So now we're going to find the derivative of sine of 2x. So the derivative of sine of 2x, if you want to write it off on the side, you can. I'll write it like this. Sometimes I write dx of sine of 2x. We have to do the same thing. We have to do the chain rule with that. So you do the derivative of the outer part, which is cosine of x, and then that's actually cosine of 2x, times the derivative of the inner part, which gives us 2. So I end up getting 2 times the cosine of 2x. My final answer for this one is 2e to the sine of 2x times cosine of 2x.